In this video, let us solve more problems based on trigonometric identities. Here we have a question which reads like this. Prove the following identities. We've got one of them here. Sine theta plus cosecant theta the whole square plus cos theta plus secant theta the whole square equals 7 plus tan square theta plus cot square theta. So what we need to do in this problem is prove that this LHS, that is the left hand side, equals the right hand side. So we need to start off from this expression, that is sine theta plus cosecant theta the whole square plus cos theta plus secant theta the whole square. Start off with this and then end with this. That's what we have to do. So let's start off now. This is of the form a plus b the whole square. This is also of the form a plus b the whole square. So I hope you remember what is a plus b the whole square, which is a square plus b square plus 2ab. So in this case, it is sine theta plus cosecant theta the whole square. So sine theta plus cosecant theta the whole square is sine square theta plus cosecant square theta plus 2 sine theta cosecant theta. If you're wondering how is it, I'll just repeat it for you. This is of the form a plus b the whole square. Sine theta is a and cosecant theta is b. So therefore, a square is sine square theta, b square is cosecant square theta, plus 2ab plus 2 multiplied by a, which is sine theta in this case, into b, which is cosecant theta in this case. So now, applying the same concept, cos theta plus secant theta the whole square. That is nothing but cos square theta plus secant square theta plus 2 cos theta secant theta. So now, let's retain these things, sine square theta plus cosecant square theta plus 2 sine theta. Now, what is cosecant theta? Cosecant theta is nothing but the reciprocal of sine theta. So, we've got cosecant theta as 1 by sine theta plus cos square theta plus secant square theta plus 2 cos theta. What is secant theta? Secant theta is nothing but the reciprocal of cos theta. So, therefore, I'll write secant theta as 1 by cos theta. Now, sine theta gets cancelled. That is 1, 1. Cos theta gets cancelled. So, all we are left is sine square theta plus cosecant square theta plus 2 plus cos square theta plus secant square theta plus 2. So, now let's regroup this again. So, let's write sine square theta plus cos square theta plus cosecant square theta plus secant square theta plus 2, right? So now we've got sine square theta plus cos square theta as 1, right? So we need 7 plus tan square theta plus cos square theta. We've got 2 plus 2, which is 4, plus 1, 5. We need 2 more, right? So now what we have to do is sine square theta plus cos square theta is one of the most basic trigonometric identities, which is 1. Now we can write cosecant square theta as 1 plus cot square theta, right? Because that's what we need. We need a cot square and a tan square. So use cosecant square theta to get 1 plus cot square theta, because cosecant square theta equals 1 plus cot square theta and secant square theta equals 1 plus tan square theta. Plus 2 plus 2 is 4. So now let's add 1 plus 1 plus 1 plus 4, which is 7, plus tan square theta is here, and then plus cot square theta. So here we are. This is the RHS. This is what we needed. So let me write in brackets whatever I used, the formulas that I used. I used sine square theta plus cos square theta equals 1 in this case. And in this case, in the place of cosecant square theta, I wrote cosecant square theta equals 1 plus cot square theta, because we needed cot square and we needed more numbers. That's how you could get it. And then we had secant square theta. So what I did was, secant square theta can also be written as 1 plus tan square theta. So these are the 3 main identities that I used. And of course, the most basic one was a plus b the whole square. A plus b the whole square. I really hope you know these things by now. But even if some of you do not know, don't worry, because we've got to learn at some point, right? So a plus b the whole square equals a square plus b square plus 2ab. You just have to apply this, that's all. And then nothing much. You need to like group a little bit. Just see what you need on the right hand side and accordingly work your way up there. So here we have 7 plus tan square theta plus cot square theta. So we've started off with this and we've ended up with this, which is what we wanted. So, all right, let's solve another problem similar to this. we need to prove that 2 secant square theta minus secant to the power 4 theta minus 2 cosecant square theta plus cosecant to the power 4 theta equals cot to the power 4 theta minus tan to the power 4 theta. Well, don't worry, just by looking at it, it may seem a little complicated, but it's a very, very simple problem if broken down. Let's first do a little bit of grouping here. Let's write cosecant to the power 4 theta minus 2 cosecant square theta minus of secant to the power 4 theta minus 2 secant square theta. Now, you need to try and understand what I've done here. I've just taken plus cosecant to the power 4 theta as it is, minus 2 cosecant square theta as it is, and then I've used brackets to cover this up. And then minus of, I've opened brackets, and I've written secant to the power 4 theta as positive secant to the power 4 theta inside the bracket. Because if you remove the bracket, this negative is going to get multiplied to secant to the power 4 theta. And then I've written 2 secant square theta as minus 2 secant square theta inside the brackets, so that when you remove the brackets, you have negative into negative, giving you a positive. So nothing has changed yet. As far as why I've done this, well, we'll find that out. Now, the next step is cosecant to the power 4 theta minus 2 cosecant square theta. Let us add 1 to this one, and then let us subtract 1 to this. We can add and subtract 1 in the same equation. Doesn't change the value of the equation. So here I write plus 1. The reason I actually have to write negative 1, but we've got negative outside the bracket. So if you remove the bracket, this one is going to become negative 1. This negative 1 and this positive 1 is going to get cancelled, and we are going to get back this. So we haven't deviated at all. We're just manipulating it. That's all, to our conveniences. Now I'll tell you why. You will figure out why I'm doing this. Now, if you notice carefully, this is of the form a square plus b square minus 2ab. Well, I'll just write that down. I can write cosecant to the power 4 theta as cosecant square theta the whole square, which is a square, plus b square, that is 1 square, minus 2, a is cosecant square theta, right? So 2 into cosecant square theta, 2ab, b is 1. So, right, I'm going to write 1 here. So that is what it is. Now, let me use a bigger bracket here, and then I'll use a bigger bracket here. So here we are. We can write secant to the power 4 theta as secant square theta the whole square, plus b square, that is 1 square, minus 2ab, 2 into a is secant square theta, 2ab, right? So b is 1. So here we are. Let me even write a bracket here. So we've got a square plus b square plus 2ab. A square plus b square plus 2ab. So we can write this as what? A minus b the whole square, right? Because a minus b the whole square is a square plus b square minus 2ab. So I'll write a is nothing but cosecant square theta. B is nothing but 1. So a minus b the whole square. Here is the negative sign. And again here, a minus b the whole square. So we've got cosecant square theta minus 1 the whole square minus secant square theta minus 1 the whole square. So let's consider this. Now we know that cosecant square theta minus 1 is cot square theta the whole square. And secant square theta minus 1 is tan square theta the whole square. The square is retained here. So what we needed, so cot square theta the whole square is nothing but cot to the power 4 theta, and tan square theta the whole square is nothing but tan to the power 4 theta. So here we are. This is the RHS that we need on the right hand side. So we started off with this, and we proved it is equal to cot to the power 4 theta minus tan to the power 4 theta. It seemed a little complicated, but it's like pretty simple. Now let me just quickly write the list of identities that I used in this video so that you don't wonder, at the end of the problem, what have I done where. So the major thing that I've done is a minus b the whole square, which is a square plus b square minus 2ab. That's what I've done here. Treated this as a minus b the whole square, or a square plus b square minus 2ab. Actually, it is a square minus 2ab plus b square. It's all the same. And then here, cosecant square theta minus 1 is cot square theta. Cosecant square theta minus 1 equals cot square theta. And then here, secant square theta minus 1 equals tan square theta. This is the two major things that you need to know in order to solve this problem. And then you do the mathematical thing, you're going to get the right hand side. So here we are. So this ends this video of a set of 2 problems. Pretty standard trigonometric problems.